Welcome to another lecture on electrical circuits 1. Today we'll be doing comparison between node voltage method and mesh current method on solving electrical problem. So this one is the example that we are going to do today. So we'll try to solve this problem first by node voltage method and then by the mesh current method and see what might be the best option to do, like the efficient option to do. So the question is asking us to find the power developed by this 4 ampere current source over here. So few things to note on this circuit diagram is we have a independent voltage source which supplies 128 volt here, and then we have a current controlled voltage source or dependent voltage source which which supplies voltage of 30 ix, which is controlled by the current here and the 4 ohm resistor, which is given by ix. So we'll start solving this problem first by the node voltage method. And then we'll solve using the mesh current method. So let's do with this node voltage method. So before starting this problem, I will do the same as usual. I will start by asking few questions. So first one is, how many nodes do you see in this circuit diagram? So if you guessed 6, that is correct. So we have one node here, we have other one here, this is 3, this is 4, this is the 5th node here, and this is the 6th node here. So we have 6 nodes. So if we are doing node voltage method, what do you think will be the good choice for reference voltage? So the reference node. So this one here will be a good reference node, because if we consider Vref is equals to 0, then we'll at least have one more node with known voltage, which will be this node. So this is the one. So here it will be 128 volt. So now tell me how many independent node we have. Yeah, so independent node will be anything besides this node and this node, because we don't know the voltage across these 4 nodes. So that will be 4 nodes. Let's assign those nodes values. Let's say this one is V1, this 2 is V2, this is V3, and this is V4. Okay, so our first step in the node voltage method, so that was assigning the current directions through the resistive elements. So step 1 was to assign the current directions. Assign current directions through the resistive elements. In node voltage method, you can assign those directions arbitrarily in any random direction, but in mesh current method we try to follow a at least consistent pattern, like clockwise or anti-clockwise. So for here, let's assign the current direction. So Ix is already given by question, so let's say this is positive, negative. So here I'll assign this direction for this current, positive, negative, and let's assign this direction for this part of the circuit, positive, negative, and let's say this is positive, this is negative. Let's say this is positive, this is negative. So you can assign any direction, doesn't matter, because ultimately when you get the values, those values will be negative if you assign the opposite direction. So it doesn't matter at all for this node voltage method. So the next step of the node voltage method is to write the Kirchhoff's current law, right? So we start doing the Kirchhoff's current law. So we can do from the unknown nodes. So we have V1, V2, V3, and V4. Let's start with KCL at node 1. Okay, so if you look into KCL at node 1, we have current Ix coming in, which is given by 128 minus V1 divided by 4 ohm. We have two currents going out, this current and this current. So the current flowing through this 3 ohm resistor is V1 minus V2 divided by 3, and the current flowing through this 6 ohm resistor is V1 minus V4 divided by 6. So we'll write that here. 128 minus V1 divided by 4 ohm resistor is equals to V1 minus V4 divided by 6 ohm resistor plus V1 minus V2 divided by the 3 ohm resistor. If you simplify it, you will get something like 9V1 minus 4V2 minus 2V4 is equals to 384. Let's say this is equation 1. And if you look into the circuit, you will realize that there is a current controlled voltage source, and it is between two independent nodes, independent unknown reference nodes. So we don't have the voltage values for V2 and V3, and there is a voltage source in between those two, V2 and V3. And if you recall from our lecture, so anytime you have two independent nodes that are connected by a dependent or independent voltage source such as this one, there is an opportunity to apply supernode. So in this case, we can apply supernode here. So let's say in this part, we can apply supernode. So if we apply supernode, if we apply Kirchhoff's current law at this supernode, the current coming here will be this 4 ampere current, and this current coming through the 3 ohm resistor, which is V1 minus V2 by 3 ohm again. So there are two incoming currents, and there is another current coming here. So this current is V4 minus V3 by 5. So sum of these three currents should equal to 0 for the supernode. So we do that here. We apply KCL at supernode. So 4 ampere coming from the top constant current source, and then we have V1 minus V2 divided by this 3 ohm resistor, that is the current flowing through the 3 ohm resistor, and then V4 minus V3 divided by 5 is equals to 0, because everything is going towards the supernode, so everything is on the right side here. So let's simplify this and write in a simple equation. So this will give us 5V1 minus 5V2 minus 3V3 plus 3V4 is equals to minus 60. So that will be our equation 2. Okay, so if you recall from earlier lectures, anytime we have supernode, we do KVL around the supernode. And if you are doing mesh current method, anytime we have super mesh, we do KCL around super mesh. So next step is doing KVL around supernode. So for supernode is pretty easy and straightforward, because the polarity, the voltage is higher on this side and lower on this side. So what this means is V2 minus V3 should equal to this value. So that's basically the KVL around supernode. So you can simply write as voltage difference across supernode V2 minus V3 is equals to 30 Ix, that is the dependent voltage source, or just put everything on the same side. V3 minus 30 Ix is equals to 0. So this will be our third equation. Now if you realize here, we have V1 to V4, so 4 unknown variables. we have ix, which makes the fifth unknown variable, but we only have 3 equations so far, so we cannot solve these 3 equations to get those 5 unknown values. So what we can do is we need 2 more equations, and one thing you can relate is that can come from ix, as we have been always doing around, and we have to find another way to get another KCL around one of those independent nodes. So what we can do is we can write a KCL around this node, because then b4 is already in the previous equation, v1 is in the previous equation, and v3 is in the previous equation. So we don't add any unknown parameters, but we add extra equation here. So that gives one equation, and then other equation comes from the relationship between the this ix and the voltage. So this can come from this Ohm's law in this circuit here. So ix is basically nothing other than 128 volts minus v1 divided by 4 ohm. So using those two equations, we can get extra using those two nodes, we can get extra equations. So let's do the dependent variable first. So the dependent variable, we can apply Ohm's law. So if you apply Ohm's law around node 1, what you get is 128 minus v1 divided by 4 is equals to ix. So this comes from, again, this part of the circuit. So 128 minus v1 divided by 4 is ix. That's the Ohm's law there. And if you simplify it, you'll get minus v1 minus 4i minus v1 minus 4ix plus 128 is equals to 0. That is going to be our fourth equation. And I mentioned earlier that we can get another equation by using KCL at node 4. So KCL at node 4. We are trying to avoid the KCL at node 2 and 3 here. That is just because we have this dependent voltage source, which makes the equation complicated because we have to go through the super node. And since we already used v1, now we can use v4 to get extra equation. So KCL at node 3 will be 0 minus v4 divided by 2, which is this current going into the node. So 0 minus v4 divided by 2, and then there is another current coming, v1 minus v4 divided by 6. So we add this plus this, which should be equal to v4 minus v3 divided by 5 ohm. So write it down again here. So KCL at node 3 is then v1 minus v4 divided by 6 is equals to v4 minus v3 divided by 5. Now if we simplify this, we should get 5v1 plus 6v3 minus 26v4 is equals to 0. This becomes our fifth equation. So now we have 5 equations and 5 unknowns. So next step is we can solve the system of equations. Solve the system of equations. So we can write that in matrix form, and you can directly solve using calculator if the calculator has the capacity to do so, or you can simplify using Cramer's law and calculate the modulus of each modulus and divide that. So writing this in matrix form will give something like 9 minus 4. So this is basically v1, v2, v3, v4 and ix. So if you don't have any of those parameters in the equation, you can just replace by 0. So 5 minus 5 minus 3, 3, 0, 0, 1, minus 1, 0, minus 30. You have 5, 0, we have 6 minus 26, 0, we have 1, 0, 0, 0, 4, and you have 5 unknowns, which are v1, v2, v3, v4, and ix. You write the value on the other side. So 384 from first equation minus 60, 0, 0, and 128 from fourth equation. So you can solve this equation to get the values. So solving, it will resolve into v1 is equals to 108 volts, v2 is equals to 138 volts, v3 is equals to minus 12 volts, v4 is equals to 18 volts. Finally, ix is equals to 5 ampere. So try to solve this. If your calculator doesn't have this capacity, please apply Cramer's rule and solve this. Do it yourself. Now the question was power across the 4 ampere resistor. So now we find the voltage. So before that, we have to find the voltage across the 4 ampere. So voltage across 4 ampere. I'm just going to write the circuit diagram of just the current source part, nothing else. So everything will be same. So we know here it is 128 volts, and we know this was v2, and we know this was 4 ampere, and we say since current is following in this direction, we say this is positive, this is negative, this is vx. And since this is an active element, we use active sign convention. So v2 minus 128 should give us the value of bx. So we know the value of b2 here, 138 volt. So 138 minus 128 is equals to 10 volts. So vx is 10 volts. So power across 4 ampere resistor will be, since the current is leaving the positive terminal from the active sign convention, we know that then that will be minus v times I. So minus vx times I, which is 4 ampere. So that will be minus vx is 10 times 4 is equals to minus 40 watt. And the negative sign, it means that the current source is actually delivering the power. So delivering the power. So this is the solution of the given circuit diagram using the node voltage method. Now we are going to solve the same problem using mesh current method. And we should get the same values because we are solving the same problem. Let me redraw the diagram so that it is easier for you to follow. So this plus, this was negative, so this is 30 ix, and so we have another resistor here, the resistor here, another resistor here. So the voltage source is 128 voltage. This is 4 ohm, this is 3 ohm, this is 6 ohm, this is 5 ohm, this is 2 ohm, and you know this is 4 ampere. So the question is, how many meshes do we have? Yeah, so we have 3 meshes. So let's say this one is first mesh with current I1. Let's say this is the second mesh with current I2. Let's say this is the third mesh with current I3. So the next step is the first step was to assign current directions, right? So first step was assign current directions. And polarity. So that is in the mesh current method we usually do that just for the exterior branches, and because interior branches will have more than two current source, so that is dependent on which mesh we are trying to analyze. And looking into this diagram, we have only two exterior branches. So this is the exterior branches, so current flows from here to here in this sign convention. So we'll say plus minus and then plus minus, and we'll leave the internal terminal as it is for now. One thing you should know just by inspection, that out of those three currents we already know one of those values, which is I1, because I1 is basically the same current flowing through the current source. So before even we apply KVL, we know by inspection current I1 is equals to 4 ampere. And now with that we can start applying KVL. So let's apply KVL around mesh 2, because we already know I1, we don't have to apply KVL around mesh 1. So around KVL mesh 2, you can see if we start from here, it's going from negative to positive terminal, so that will be minus 128, plus we have 4 ohm resistor here. The current I2 is flowing in this direction, but then we have I1 coming opposite direction, so we have 4 times I2 minus I1, but we already know the value of I1, so rather than writing I1, I'll just put it as 4, plus now we have 6 ohm resistor, and the current I2 is flowing in this direction, clockwise direction, but then I3 is going anti-clockwise, so that will be 6 times I2 minus I3 is equals to 0. Is that right? No, because we still need to consider this 2 ohm resistor, so that plus 2 ohm resistors time I2 is equals to 0. Now the loop is complete. Minus 128 plus 4 times I2 minus I1 plus 6 times I2 minus I3 plus 2 times I2. So if you simplify this equation, you will get 12I2 minus 6I3 is equals to 144. So 144 you can cancel by 6 to get even simpler form, but I'll keep it this for now. And now we can apply KVL around mesh 3. KVL around mesh 3. So if we apply KVL around mesh 3, and let's say we start from 6 ohm resistor, so this will be 6 times the current flowing clockwise direction, that will be positive I3, but then we have I2 coming in opposite direction, so 6 times I3 minus I2 plus 3 times I3 flowing in the clockwise direction, but I have there I1 is in the negative direction, so plus 3 times I3 minus I1, and then from positive to negative terminal, so we have 30 Ix volts, and then positive to negative terminal plus 5 I3. So writing this down, 6 times I3 minus I2 plus 3 times I3 minus I1. We can simply write I1 is equals to 4. We don't have to do that because we know the value of I1. I'll just write 4 plus 30 times Ix plus 5 I3 is equals to 0. We also know, if you look in here, in here if you see Ix, so that was Ix, right, from earlier question, if you look into this diagram, Ix is basically nothing more than this I2 current flowing here minus this I1 current. So I1 is 4, so Ix can be simply written as, so we substitute Ix, so Ix is basically nothing other than the I2 minus I1, which is 4. So again, it's I2 and this is I1. I2 minus I1 is Ix. Now we substitute this value in the equation and simplify it. So using that, we'll get 24I2 plus 14I3. This is 14I3 is equals to 132. So this is our second equation. Now we only have two equations as opposed to we had 5 equations in node voltage method. Now we have only 2 equations and 2 unknowns. So we can just solve equation 1 and 2. You can do matrix or you can simply manually do it because it's we only have 2 unknowns. So this will give the values of I2 is equals to 9 ampere and I3 is equals to minus 6 ampere. Now we are asked to do power developed by the 4 ampere source. Power is voltage times current, but we don't know the voltage, so we have to decide the voltage first here. So power developed by this 4 ampere source, but then still we need to decide the Vx flowing around this one. So what we can do is to determine the Vx, we can utilize the KVL around the mesh which has the source. So basically the 4 ampere loop is this I1 loop. If we apply KVL around I1, so the voltage here was 128 volt, because assuming this is the so this is 128 volt, and 128 minus 4 times, so this is the Vx here. So if we do that, we'll get minus Vx. So let me go back and realize this. So we have Vx. We can apply this around the loop. So let's see Vx. So I'll write it down here, but then I'll write again back there. So this is going from minus to plus, so it will be minus Vx. We have 3 ohm resistor times current is I1, which is 4, minus I2, minus I2, no, it's I1 minus I3, sorry, I3, and then we go here plus 4 ohm times I1 minus I2. So this will be equals to 0. So that is the KVL that is we are going to use around this loop. So writing the same thing here. So we have minus Vx, and then we had the 3 ohm resistor here, and then the 4 ohm resistor here, 4, 3, and then we had current I2 flowing in this direction, current I3 flowing in this direction, I2 in this direction, and this I1 was following in the opposite direction. So let me erase this one. So minus Vx KVL around mesh 1. So KVL around mesh 1 minus Vx plus 3 times I1 minus the current I3 was flowing opposite direction, so minus I3 plus 4 times I1 minus I2 is equals to 0, or minus Vx plus 3 times I1 is 4, and we already calculated I3, which is minus 6 ampere, plus 4 I1 is 4 again, minus I2 was 9 ampere, so is equals to 0. If we calculate Vx from this equation, you will get 10 volt, and therefore power P is equals to minus V times I. Minus is because we are using the active sign convention, as long as current is leaving the positive terminal, we use this formula using the active power convention. So minus V is 10 volts and I is 4 ampere is equals to minus 40 watts, and again the negative sign implies that the current source is delivering power. So now we compare the node voltage versus mesh current method. Let's see how long is the mesh current method. Already done here, but if you look into the mesh voltage method, they have this big matrix equation. They have like 5 different equations, so we can definitely say that in this situation mesh current method is more efficient, but that is not always the truth. Sometimes node voltage can be efficient. There is no strict rule, you can apply anything, but if you follow like a few methods, then you can decide whether you want to use node voltage or mesh current method. So comparing these these two methods, so node versus mesh method. So these both methods, they provide a systematic approach for finding the electrical quantities in complex circuit. I'll write this. Both methods provide systematic approaches for finding electrical quantities in complex circuits. But how do you know which method to use? So there are a few steps. If you follow that might actually help. So the following questions may help in determining which method to use. So first question you always ask is which method results in fewer unknowns. So that is the to go. If one of the method results in fewer unknown than other, always go for that. Which method results in fewer unknown? And if that is not the case, let's say both method give you the similar number of unknowns, then the next question to ask is what electrical quantity you are trying to find. What electrical quantity are you finding? In this case, if you are trying to find voltage, maybe node method is good, but that is not guaranteed. That depends on the number of steps and the complexity. The node method may be more direct. If you are trying to find the voltages, that is the ultimate subject of interest. Let's say if you are trying to find current, then maybe mesh method may be more direct. If you're trying to find current, mesh method may be more direct. And the third parameter that decides which method to use is circuit structures. If both method have same number of unknowns, then maybe look into if there are any super nodes or super mesh. And if you have super nodes, probably node voltage method is better option, but if you have super mesh, maybe mesh current method is a better option. So look for supernodes or super mesh. So supernode is when you have two unknown two independent nodes and you have a constant current source, while super mesh you have a two unknown nodes and a voltage source. So depending on that, decide either node voltage method is a appropriate method or the mesh current method. To do that, let's look into another example. So here we are asked to determine the power developed by the 2 ampere current source, and the circuit diagram follows like this. We have a voltage source which is 25 volts. We have another voltage source which have 20 volt, and we have a constant current source which gives 2 ampere. So we are asked to determine the power developed by this 2 ampere current source, and the resistors are 15 ohm and 10 ohm. So the question is, which method would be most efficient? So let's go through the point earlier. First question to ask is, which method results in fewer unknowns? Okay, so let's say we are going to use node voltage method in this situation. So let me make another circuit diagram. Let's say if we are trying to do node voltage method. Okay, so let's compare those, node voltage versus mesh current. So if you are deciding to go for node voltage method, plus minus, this is 2 ampere, 10, 25 volts, 20 volt, 15 ohm. So if we're going to decide node voltage, we can select this as a reference node because this has most common number of elements, and if we do that, if we ref is equals to 0, then this will have 20 volts, this will have 25 volts, and the only unknown node is this one. So this will be Bx. We can assign current directions, plus minus. So using this method, we have only one unknown voltage here. Let's say if we were to use the mesh current method. Volt, this is 25 volt, this is again 10 ohm, and please make these figures separately so that you can understand what's going on here. So if you are doing the mesh current method, you have to use two different meshes, I1 and then I2, and unlike the earlier problem, you cannot say the value of either I1 or I2 just by intuition, just by looking into the circuit. So here we have two unknowns, I1 and I2. Those are our unknowns. Here our unknown is Vx. So it will make sense to use node voltage method in this case. So let's solve this problem using node voltage method. So now we apply KCL at node X, which is Vx here, because that is the only unknown here. So KCL at node X. If we do that, let me write in this side, so it might be actually be helpful. KCL at node X. So this is 20 volt minus Vx, 20 volts minus Vx divided by 15. That is the current coming in, and another current coming in is that 2 ampere constant current source. The current leaving is Vx, this one, so which is Vx minus 25 divided by 10. So there is only one unknown parameter here. If you solve this, if you take 30 as a, so if you take 30 as a common denominator, you have multiply by 3 Vx minus 75. If this goes to other side, then that will be minus 2. 15 times 2 is 2, minus 40 plus 2 Vx, and then 2 was in other side. So if you solve that, so you have 5 Vx is equals to 60, so 2 times 30 plus this is 105 plus 75 plus 30, 105, 115, right? So yep, 115. So Vx is equals to 175 divided by 5, which is 35 volt. So now power across 2 ohm resistor is basically power is equals to V times I. So 35 times 2, which will give 70 watt. So we solve this in simple manner using node voltage method. So yeah, we finished the node voltage versus mesh current method in this lecture. In next lecture, we'll look into different types of source transformation, and next lecture will be in class on Monday. See you all. Thank you.